Don't forget to subscribe and press the bell icon to never miss a video from testbook.com.
Hello friends, a very good evening to all of you. So guys, I hope everything is going well. बहुत सारा रिवीजन चल रहा है. So आज क्या तारीख है? आज 8 जनवरी है. Today is 8th of Jan and only a few days are left with you, है ना? So civil engineers less than 30 days. मतलब 30 days भी कहाँ, 25 days के करीब. And for mechanical guys almost 37 days. 37, right? 37 days. So please revise a lot. ठीक है ना? Now yesterday also I told, so a vacancy has come out. The vacancy has been released by Airport Authority of India Limited, and that is air traffic controller. So definitely this is a very good job, and those people who are not interested in technical exam, so it's like you can't even say completely non-tech. It has good amount of maths, engineering maths, similar to GATE exam. It has physics in it, 11th and 12th class physics in it, and there will be English, reasoning, aptitude. So those people who are not interested in GATE exam, pure technical exam, and are looking for some other exams, they can definitely opt for this one. Okay, so I think let us continue without wasting any time. So in this very short video, I am simply going to revise flow classification. So ऐसा भी नहीं है कि we are revising everything. So my ultimate aim is कि those students who have already done the subject, so for them these can be short revision sessions. So yesterday I had a class on local and convective acceleration. Before that we had a class on velocity, discharge, mean flow velocity. So like this in order we are moving by. So in the same order in which I teach during the classes, during regular classes or crash course, in the same order I am going through these videos. Now particularly from last 2-3 videos, you might have observed that I have not given you very typical kind of question, and the same scenario today also you will see, because from these topics the questions have been quite simple. So I just want to give 2 difficult questions, because in this particular chapter now, if I will increase the level of question, that will become more mathematical, and that is not required for GATE exam. But definitely when we are doing dynamics, we will have a much better question as compared to GATE exam. When we are doing boundary layer, the question will be much better. So I might give you a question of a ship or a boat and so on. Flow through pipes, much better question than GATE exam. ठीक है फिर? Anyways, let us, without wasting any time, let us continue. So let me give you a simple question. So I hope you remember in fluid kinematics, the ultimate purpose is to find out the information that can be derived, the information that can be expressed through the velocity vector, right? Obviously, one of those informations is acceleration, but see, there are some other informations as well. So a velocity field is given to me, and it says the velocity field is x z I cap minus y z j cap. Only this is the velocity field. Okay, so velocity field is given to me. So whenever we say field means a Eulerian function, a function of space and time. So every term, whether a scalar or a vector, that is represented as a function of position and time. So this is a field. So velocity field is given to us, and they are asking you find out any kind of possible information that you can. Any kind of information that you can find out. So say for example, what is the very first information that you can predict from the velocity? I think you can predict the acceleration. Right? So acceleration, it is going to have some components. Obviously, one is ax, ay, az, right? So these are the components of acceleration that can be predicted from velocity field. And let us quickly go through it. However, today we want other informations. So when I talk of ax, that will be u del u by del x plus v del u by del y plus w del u by del z plus del u by del time. So obviously you are going to say, based on the expression given to us, we know the term with I cap, that is the x component of velocity, that is u. The term with j cap, that is y component of velocity, that is minus v. And obviously in the velocity field there is no k cap. So actually k cap is multiplied by 0. So w is going to be 0. So once w is 0, this term will become 0, right? W is 0. And secondly, if you will see u is not a function of y. So if u is not a function of y, del u by del y will also be 0. Also, u is not a function of time. So del u by del time will also be 0. So what we are left with? We are left with ax is equal to u, which is xz, into del u by del x. Now once we do del u by del x, so z will be treated as constant because this is a partial derivative. So once you do del u by del z, I think that del u by del x, z will be treated as constant. What is the power of x? That is 1. So partial derivative of x will be 1 only. So I think this will be multiplied by z and we will have xz square. So this is the acceleration component along x direction. Similarly, if I write acceleration component along y direction, so I will have u del v by del x, but v is not a function of x. So del v by del x will be 0. So first term is going to be 0. Plus v del v by del y. What is v? It is minus yz. Del v by del y. So that will become minus z. Obviously when we are doing del v by del y, z will be treated as constant. And what is the power of y? 1. So this derivative becomes minus z. Then you will have w del v by del z. But again w is 0. So third term will be 0. And del v by del time. Velocity is not a function of time. So this term is going to be 0. And this will become yz square. And what about az? अरे भैया w तो वैसे ही 0 है. किसी भी point पे w 0 है. At any point w is 0. So derivative of w will only be 0. So there is no acceleration component along the z direction. So physically this situation simply represents that there is a coordinate system and fluid is moving in this space. So if I take a point x, y, z, then at a particular time instant t, there will be a particle which is passing through the point. So for this particle, the velocity components u, so velocity component u is xz, velocity component v is minus yz. And in the same direction, the acceleration components are xz square. Acceleration components are yz square. So for the particle, these are the components of acceleration. So if they have given you a point, say for example 1, 2, 3, for that point you can write down the numerical values of these terms for any time instant, right? So this we had done in the previous session also. But what are the other informations that you can find out from velocity? So in last to last session, we took a random cross section. We took a random section like this. And for that random section, we found out the discharge also. So what you will do integral of UdA and you will consider all the points that lie on this area. But to find out the discharge, you will take only U component of velocity. If the cross section looks like this, somewhere here we have the cross section, then you will take integral of VdA. है ना? How do you find out discharge? By integral of perpendicular component of velocity. So this is the other information, discharge for a section. But today we are going to talk about other important informations like whether the flow is steady or unsteady, uniform or non-uniform, linear, planar, spatial, 1D, 2D, 3D, rotational, irrotational, is there a linear strain rate or not, shear strain rate or not, volumetric strain rate or not, है ना? I mean incompressible or compressible. So all these things we have to write down. So what we have the velocity field which is given as x, y, I cap, x, z, I cap minus y, z, k, j cap, right? This is given to us. Now, whenever you check steady, unsteady, है ना? Whenever you check steady or unsteady, so steadiness means that a property at a point, we are not comparing multiple points. We are talking of property at a point. Hello Aryan, how are you? So Aryan, beta, I think this should not happen. एक बार अपना वॉल्यूम चेक करो. मैं चेक करूं यहां से. लेट मी चेक कि ऑडियो आ रहा है. नहीं, ऑडियो तो आ रहा है बेटा. यहां से ऑडियो आ रहा है. So please check your sound. I think I will have to write to you. Hi Aryan. Okay. So Aryan, beta, I checked. So actually I have two screens. In one screen YouTube is running. So when I check the voice over there, it's giving me sound. So please check your connection, beta. Steadiness or unsteadiness. So please remember, steadiness means check the variation at a point with the time. So you focus only on the inlet of turbine. You do not compare inlet and outlet of turbine. You focus only on inlet of turbine or only on outlet of turbine. Now at the inlet of turbine, if the pressure is changing with the time, velocity is changing with time, or temperature is changing with time, you would say that these properties are functions of time. These properties are unsteady. Right? So if a property changes with the time, then those properties are unsteady. So I think Aryan is like giving some kind of emojis. So this emoji, I don't think this emoji is good for me. Okay, anyways. So if the property is not a function of time, then we call the property to be steady state. So right now I am getting the light from the tube at a constant intensity. So the tube is operating at a steady state. When the fan is running at a constant speed, I am getting a constant discharge of air. So flow conditions are steady, right? This is what the steadiness means. And what here we can see, velocity components are not a function of time. So definitely the flow is steady. And also since velocity components are not a function of time, so steadiness also means that local acceleration is 0. So I hope you remember in this question also, del u by del time, del v by del time, del w by del time, they are 0 because velocity components are not a function of time, right? Okay, now let's check for the next part. So I think the very next part is uniform and or non-uniform flow. Uniform and non-uniform flow. So obviously during the class, we had a lot of discussion on this. So I said when we check uniformity, it is only in terms of velocity field, not in terms of pressure. And that too, when we check uniformity, we are not talking of the actual velocity at a point, but we compare the velocity profiles of two sections. Particularly for flow through pipes, we do not check the velocity at a point, but we compare the velocity profiles. That situation is for internal flow. पर जब हम external flow की बात करते हैं, then for external flow, uniformity simply means if two points have different velocities, then the flow is non-uniform. If all the points have same velocity, then the flow is uniform. Now in this particular case, definitely u is given as, what is u given as? I think u is given as xz. What is v given as? It is given as minus yz. So definitely a velocity component depends upon the position of the point. Velocity at a point depends upon the coordinates of the point. So different points will have different coordinates. They will have different velocities. So definitely the flow is non-uniform. So the flow is steady but not non-uniform, right? Now the next thing was linear, planar and spatial. Linear, planar and spatial, right? So when you say linear, so I hope you remember when in the flow there is only one velocity component, then all the particles are moving parallel to a single line. They are moving parallel to a single line, maybe x direction. So if there is only x component of velocity, all the particles are moving parallel to x. That will be called as linear flow. If there are two velocity components, particles are moving parallel to plane. So here in this case, there are two velocity components, one along x, one along y. So all the particles are moving in xy plane. So this is a planar flow. And if there are all three velocity components, that will become spatial flow. But this one is an example of planar flow. And when we talk of the next classification, that is 1D, 2D and 3D. So if the velocity vector, entire velocity vector, not single velocity component, entire velocity component. So if entire velocity vector depends on single space coordinate, that is 1D flow. It depends on two space coordinate, that is 2D flow. It depends upon three space coordinate, that is 3D flow. Now in this particular case, it depends upon x, z and y. So velocity vector depends on all three space coordinates. Therefore, this is a 3D flow. So please understand, many times I have told you that this is a wrong interpretation in our books. So generally, whenever we say 2D flow, we say two velocity components. No, it's not like this. 2D flow does not mean how many is the number of components. 2D flow means on how many space coordinates does the velocity vector depend. तो अगर आप थोड़ा सा एडवांस लेवल पढ़ेंगे, जैसे कॉन्टिन्यूम मैकेनिक्स पढ़ेंगे, कॉन्टिन्यूम मैकेनिक्स में फील्ड थ्योरी पढ़ेंगे, देन यू विल कम टू रियलाइज अबाउट इट. सो पहले मुझे भी नहीं पता था कि देयर इज सम फील्ड थ्योरी. सो आई हैड अ स्मॉल डिस्कशन विद द सर सिद्धार्थ सुराना सर एंड ही टोल्ड मी. So in field theory, you can have a better perspective of Lagrangian approach and Eulerian approach. But the point is कि अभी ना for GATE exam, you do not need that much deep concept. So whenever I explain these things, so we start with Lagrangian and Eulerian approach in the very beginning of subject, and that I explain with the traffic analysis of a city, or sometimes the migration of birds or migration of fishes, है ना. इस तरीके से कभी कभी different examples लेते हैं जिसमें ट्रैफिक एनालिसिस कॉमन रहता है. शायद एक बार मैंने बैट माइग्रेशन से सिखाया था, अब मुझे याद नहीं है किस बैच को सिखाया था. Okay, so this is a planar 3D flow. Now the question is whether the flow is rotational or irrotational. Question is whether the flow is rotational or irrotational. So obviously, in order to check rotationality, we are going to find out the vorticity of the flow, है ना? So how do you denote vorticity? By ohm vector. Now generally once mistakes students do. So what they say, the vorticity, that is the twice of angular velocity. Now we should remember, this vorticity does not mean that the particle is moving on circular path. Vorticity does not mean that particle is revolving. Vorticity means particle is rotating. The particle is changing its orientation about its own axis. Rotating about its own axis. It is changing its orientation in the space. So please note, actual velocity, velocity vector capital V, that says the particle is changing position, but omega vector, it says particle is changing orientation. So there is a difference, right? So अच्छा, so मेरे पास क्या कमेंट आया, मेरे पास आर्यन की इमोजीज आई हैं. So these are like they are those what you say shit emojis. ठीक है यार, अरे यार इतना बेकार पढ़ा रहा हूँ, मतलब he is sending me shit emojis. चलो ठीक है, anyways let me check if there is any important. ठीक है. Oh, okay, so I think Aryan got a little irritated. So I don't know what happened with his speakers, but from here the audio was fine, I think. Chalo, anyways. So vorticity is equal to twice of omega vector. Now what mistake student do? So, and actually that can be useful in some of the cases. So students say कि भैया vorticity is given as del v by del x minus del u by del y. And in fact, in lot of questions you have, in fact, sometimes you yourself derive it. This is how you get vorticity. So in this particular case, v is given as minus yz. U is given as xz. So what will be del v by del x? I think v is not a function of x. So del v by del x will be 0. U is not a function of y. So del u by del y will be 0. So vorticity we are getting as 0. So expression of vorticity at any point is 0. So particles are not rotating about their axis. Particles are definitely moving, but they are not rotating about their axis. So flow is irrotational. But the point is, your answer will be wrong. Why? Because when we say vorticity is itself a vector, and vorticity has 3 components. Now check what will be the other components. So when you talk of vorticity along x, so I hope you remember the cyclic order. After x we have y, and after y we have z. Now z component of velocity above y and y component of velocity above z. And many times I have told you, please don't go by any formula in any of the book. The correct formula is this. समझ रहे हैं ना आप? बहुत सारी जगह पे इसको प्लस कर देते हैं, इसको प्लस कर देते हैं, यहाँ आगे का हाफ खा जाते हैं vorticity वेक्टर में. That is purely wrong. I have derived it many times in many classes from the very fundamentals. This is the correct formula. I know you might even find it conflicting with a lot of teachers on YouTube, है ना? ऐसा भी हो सकता है. But मुझ पे भरोसा रखो, मेरे जैसा FM नहीं पढ़ा सकता कोई भी. ठीक है? So this is the correct formula. So del W by del Y minus del V by del Z. Now in this question there is no W. So del W is going to be 0. And del V by del Z, so V is equal to minus YZ. V is equal to minus YZ. So del V by del Z will be minus Y. So minus of minus Y, that will become plus Y. And similarly, if you find out vorticity Y, so again remember the cyclic order. Del Z, del X, X component of velocity above Z and Z component of velocity above X, and in between there will be a minus sign. So U is definitely a function of Z. So you will have a Z over here, but there is no W in the flow. So W is going to be 0. So what does this mean? What does this mean? This simply means, physically this means, so if we take a point x comma y comma z, so for a given time instant there is a particle over here. The particle will have a linear velocity component, acceleration component, linear velocity component, acceleration component. W and az are 0, but the particle has ohm z equal to 0, so there is no rotation about the z axis, but ohm x is equal to z. So this particle is rotating around the x-axis. I should not say around. Around becomes revolution. I should say about. So it is rotating about the z-axis, and the rate of rotation is half the z coordinate. Why I am saying half the z coordinate? Because this is vorticity. Angular velocity vector is half of it. And the same particle is rotating about y direction with a rate which is equal to half of the minus z coordinate, right? Which coordinate? This is equal to how much? So let me check. Del v by del z. And acha, I made a mistake. Del u by del z. So that will become x. Del u by del z. That will become x. So this is equal to y and this is equal to x. So these are the rotations. These are the rotations. Now we can check this physically also. You know, these things you can check physically also, that this these fluid particles or fluid elements, what are the possible rotations in them? Say for example, we know that u is equal to xz. So if there are 2 points which have different z coordinate, the velocity components at those points will be different, है ना? So let me say, for example, let me take a point over here and point over here, and or maybe this point and this point, because for those points x value and y is 0 only. So let me take these 2 points. So for these 2 points, x value is equal to 1, but z value is not equal. So this particle is moving slowly and this particle is moving fast, right? So if I take a fluid element which looks like this, I think after some time the fluid element will look like this. After some more time the fluid element will look like this. So I hope you can observe, when the fluid element is moving ahead, actually it is rotating about y-axis, right? And similarly, if you consider x component, if you consider y component of velocity, so y component of velocity is given as minus yz. It is given as minus yz. So it also depends upon z. So this particle will be moving slow and this particle will be moving fast. So initially the element is horizontal, but after some time element will look like this. Then after some time element will look like this. So when the element is moving upwards, it is also rotating about x-axis like this, है ना? मतलब ये x का हो गया, by the way, ये x का हो गया, पहले वाला y का था. समझ रहे ना मेरी बात? So इस तरह से आप physically भी check कर सकते हैं. So all those people who are watching the video, did you get the point? Did you get the point? Different points will have different velocities. So let me join the 2 points with a single element. So when the single element will move up, the points of the element are moving with different velocities. So this point is moving with 1 meter per second. This point is moving with 2 meter per second. So this is what is going to happen. This is what is going to happen, right? So this particle is rotating about this axis. So physically also you can check. Okay? So in this particular case, even though this vorticity component is 0, but other vorticity components are non-zero. So the flow is rotational. What kind of flow is there? Rotational. But in gate questions you can save your time. How you can save your time? So guys, if there is a condition where ohm x is definitely 0 and ohm y is definitely 0, then your answer depends on only one term, that is ohm z. If there is a situation where ohm x is definitely 0, ohm y is definitely 0, then your answer depends only on ohm z. Now check. How do you write ohm x? So if W is not there, this will definitely become 0. And if V is not a function of Z, this will also become 0. If W is not there, this will become 0. And if U is not there, that will also become, U is not a function of Z, that will also become 0. So what happens if you have a velocity field where U is only a function of x, y, and V is only a function of x, y, and they are not function of Z, and W is also 0, in that case, ohm x and ohm y, they will be 0. You only have to check ohm z. Similarly, if you have velocity vector, so ये मैंने वैसे classes में भी किया था, पर अगर आपको याद नहीं है तो आप definitely पूछ सकते हैं. So velocity vector is equal to u, which is a function of xz I cap, and there is no j cap, and w, which is a function of xz k cap. So in that case, these components are not the function of third component. So your angular velocity components about the same directions, ohm x will be 0, ohm z will be 0, and you only have to check ohm y. So like this you can save your time in GATE exam. समझ रहे हैं ना आप जब भी रोटेशनैलिटी और इरोटेशनैलिटी चेक करते हैं आपको पहले देखना पड़ता है कि वेलोसिटी फील्ड कैसा है. सो अगर वेलोसिटी फील्ड में तीनों स्पेस कोऑर्डिनेट्स आ जाएं तो सिर्फ ओम एक्स ओम वाई चेक करके मत, सिर्फ ओम जेड चेक करके मत छोड़ देना, आपको ओम एक्स और ओम वाई भी चेक करना है. मगर आपको जिन डायरेक्शंस के वेलोसिटी कंपोनेंट दिए हुए हैं, वेलोसिटी कंपोनेंट्स उन्हीं दो डायरेक्शन के फंक्शन हैं, तो इन दो डायरेक्शन के एंगुलर वेलोसिटी कंपोनेंट 0 होते हैं और सिर्फ तीसरी डायरेक्शन का एंगुलर वेलोसिटी कंपोनेंट मिलता है, सिर्फ तीसरी डायरेक्शन की वोटिसिटी मिलती है। सो ये आप याद कर सकते हैं, ये शॉर्टकट का काम करता है। Now we have already found out the vorticity. Now also let us predict the strain rates. So in regular classes, so this time in crash course I did not prove this. I gave the formulas of these things directly क्योंकि time थोड़ा कम था. But generally I prove that at a point we can write down the linear strain rate along x, along y, along z, है ना? So what does linear strain rate represents? Linear strain rate represents when a particle will move ahead, how the sides of the particle are going to change, है ना? So how do you write epsilon dot x? This is written as del u by del x. Epsilon dot y, del v by del y. Epsilon dot z, del w by del z. Obviously w is 0 in this case, so it will become 0. Now u is equal to xz, so del u by del x is xz, derivative of xz, that will become z only because z is a constant. Del v by del y, so v is minus yz, so del v by del y will become minus z. So at a particular point, these are the rates of linear strain, how fast the length of the particle is changing per unit time. So please note, these are strain rates. These are not the total strains. These are strain rates. How fast the length is changing. How fast the body is deforming, right? Now let us move on to the shear strain rates also. So when we are talking of shear strain rates, we can denote it by phi dot or we can denote it by gamma dot also. So phi dot xy. So phi dot xy will become, so in vorticity there was a minus sign, but here you will have a plus sign. In angular velocity vector, there is a half, but here you do not have a half. So using the same thing, similar thing, so gamma dot xy, so x and y. Now y component of velocity here, x component of velocity here. Similarly, there will be a strain rate in yz plane. There will be a strain rate in zx plane. So I hope you remember. So at the same point, there was a particle. Maybe the particle is a cuboid. So particle will have sides parallel to x, y and z direction. So when the particle will move ahead, there will be a change in this perpendicularity. So maybe this side is x and this side is y. So this angle will change. So strain rate in xy plane. Similarly, this side is z and this side is x. So if this angle will change, strain rate in xz plane. And similarly, if this angle will change, strain rate in yz plane. है ना? Now, how do you write gamma dot yz, strain rate in yz plane? So first we have y, so we will write del y here. Then we have z, so we will write del z here. By the way, the order will not matter because this is a plus sign. And z component of velocity here, y component of velocity here, in between a plus sign. And similarly, gamma dot zx, so del z, del x, x component of velocity above z and z component of velocity above x, and in between a plus sign. Now w is 0, so all the derivatives, all the terms of 0, w, they will become 0. Now please check, u is given as xz, so u is not a function of y, so this will be 0. V is not a function of x, it is minus yz, so this will also become 0. Now what is v? V is minus yz, so del v by del z, y will be constant, so this will become minus y. U is equal to xz, so del u by del z, x will be a constant, so this will become x. So these are the rate of shear strains. This is how the shape of the particle is changing per unit time, the particle which is at x comma y comma z when the time instant is t. So for the same particle whose velocity components we wrote down, whose acceleration components we wrote down, whose angular velocity, I mean vorticity components we wrote down, we have also written the linear strain rates and we have also written the shear strain rates. Now when the particle will move ahead, its volume might also change. So how do you write down the volumetric strain rate? It is the sum of all three linear strain rates. That is del u by del x plus del v by del y plus del w by del z. Del w by del z. Hello Abhinav, how are you? Sure beta, why not? So beta, it's like this. So you know na shear deformation. So shear deformation means the change of shape. And how do you check change of shape? So let us suppose there is a rectangle. If the object moves ahead and the side of rectangles become big, this is not a change of shape. The shape is rectangle only. This is a change in size. But if this rectangle becomes a rhombus, then there is a change of shape. So during a change of shape, the angles will change. But during the change of size, the angle will remain constant. Now, how do you define change of shape? You define it by shear strain, that is phi or gamma. है ना? And how do you write it? So what you do? You take a linear element, you take another linear element which are perpendicular to each other. So initial angle between them is 90 degree. The new angle between them is 60 degree. So how much is the change in angle? 30 degree. So that will become shear strain, right? So what we have, this is x direction, this is y direction. So if the angle between them will change, that will become the shear strain in xy plane. Similarly, this is z direction and this is y direction. So if the angle between them will change, we will call it as gamma yz. This is x direction, this is z direction. If the angle between them will change, this is gamma xz. So like this you explain the shear strain rates. Now I am talking of volumetric strain rate. So volumetric strain rate is not based on shear strain rate. It is based on the sum of three linear strain rates. So del u by del x we have already written, that is minus z. Del v by del y we have already written, that is plus z, minus z. This is minus z and this is z. And del w by del z we know 0. So z minus z is nothing but 0. So volumetric strain rate in the particle which is at a point x comma y comma z, that is 0. So volume is not going to change. The size will change, shape will change, but the volume will not change. So volumetric strain rate is 0. So the flow is incompressible. So in this manner, you guys will find out all the information that is required. ठीक है ना? So velocity vector will not only give you the acceleration terms, it will give you the discharge terms, it will give you the mean flow velocity, it will give you whether the flow is steady, unsteady, uniform, non-uniform, 1D, 2D, 3D, linear, planar or spatial, rotational, irrotational, incompressible, compressible, है ना? All these things can be verified. And last classification is laminar plus turbulent flow. So in the velocity terms, if you have a fluctuating part, then it will become turbulent flow. But obviously there was no sort of fluctuating part in our case. So we are not going to talk about turbulent flow. Okay? So that's all for today. If you have any doubt related to this topic, please ask. Else tomorrow we will talk about the next topic. So I think tomorrow we have a session on continuity equation, and day after tomorrow we will have a session on stream function and velocity potential function. So like this every day, 40 minutes to 1 hour depending upon the topic, we will spend some time, only 40 minutes or 1 hour. I don't want to waste too much time of yours. I am already aware that you have done a lot of fluid mechanics now and we only need to revise. ठीक है ना? आपको बहुत सारे सब्जेक्ट करने हैं, तो मैं नहीं चाहता कि आप ये फ्लूइड मैकेनिक्स देख देख के या हीट ट्रांसफर देख देख के डिस्ट्रैक्ट हो जाएं. अब बस आप अपने नोट्स पे ध्यान दीजिए और इस तरह से छोटी छोटी जो रिविजन्स हैं वो करते रहिए. ठीक है? सो हाँ, गुड नाइट अभिनव. अभिनव बेटा, एनी डाउट इज देयर, प्लीज डू लेट मी नो. सो फॉर सम ऑफ माई स्टूडेंट्स देयर इज एन इंफॉर्मेशन. So with a good number of students, I was not able to do dimensional analysis in a proper manner. So right now it's 8th Jan, but definitely within a week, dimensional analysis and pumps, matlab within a few days, I will definitely have 2 sessions of it. One day to a small session, not small session, it can't be a 1 hour session, but 3 or 3.5 hour session on dimensional analysis and similarly the next day a session on centrifugal pump. तो मैं जरूर आपको ये 2 सेशंस कराऊंगा मेरे पुराने स्टूडेंट्स के लिए भी, क्योंकि मुझे पता है कि उनके ये 2 पोर्शंस वीक हैं, ठीक है ना। और बाकी अगर आपको कोई डाउट हो तो मुझे जरूर बताइए। फ्लूइड काइनेमेटिक्स का एक छोटा 1 घंटे का रिवीजन सेशन हम रखेंगे, सो उसमें आप सिर्फ नोट्स पढ़िए, उनको एक बार लिख के देख लीजिए, मगर 1.5 घंटा 2 घंटे से ज्यादा टाइम वेस्ट मत कीजिए, उसी को रिवाइज कीजिए। तो चैप्टर वाइज रिवीजन सेशन रखेंगे, बट मेरा मेजर फोकस है उन 2 चैप्टर्स पर। सो गाइस प्लीज डू लेट मी नो कोई डाउट है, अगर कोई डाउट नहीं है तो चलेंगे। और अपने फ्रेंड्स को बता दो एटीसी का रिक्रूटमेंट चल रहा है, चालू हुआ है, एप्लीकेशन फॉर्म आउट है, 14th Jan is the last date. So those who don't want to give gate paper but they are looking for jobs, obviously they can apply for ATC also. So please do let me know कोई नया इंफॉर्मेशन हो, कोई नया साइंस का कुछ न्यूज आया हो तो वो भी बता सकते हो, कोई जॉब हो तो अपने फ्रेंड्स के साथ डिस्कस कर सकते हो, कोई डाउट हो तो पूछ सकते हो, अदरवाइज वी विल लीव। कुछ मोटिवेशन बात करनी है तो भी डिस्कस कर सकते हैं। ठीक है, तो आई थिंक लेट्स लीव and all those people who will watch the video later on, you guys have my number and you can definitely contact me or you can put your doubts in the comment section also. ठीक है, thank you, bye bye, thank you.